Have you ever stopped to think about how your computer is running like a dozen different things at once and somehow doesn't just explode into chaos? Well, we're about to find out why the apps on your computer don't end up in a digital fistfight. All right, to get our heads around this, just imagine your computer is a zoo. Seriously, every app, your browser, that game you play, your spreadsheet, it's an animal. And you'd never put the lions in with the penguins. And the parrots, they'd just be flying around making a racket and stealing everyone's food. You can't just let them all run wild together.
And that really gets us to the heart of the problem, right? Every single program wants a piece of the pie. It wants memory, it wants to use the network, it wants access to your files. So if one app goes rogue or, gets a virus, how does your computer stop it from wrecking everything else? How do you keep the peace in this digital zoo?
Well, the answer comes down to one single powerful idea: isolation. It's this art of building invisible walls and fences and cages right inside your machine. It keeps every program in its own little space. This, right here, is the secret sauce for a stable, secure computer. Okay, so let's get into how this isolation thing actually works. We're going to start with the most basic form of it, which is the simple sandbox. The whole idea here is pretty straightforward. Let the apps play, just make sure they can't break any of your other toys. In the concept, it's actually beautiful in its simplicity. A sandbox is just a restricted area. So when you open a PDF from a weird email or visit a new website, your computer basically says, okay, you can do your thing, but only in here. Don't you even think about touching anything outside this box. All the mess stays inside. And you're using these things all the time, probably without even thinking about it. Each tab in your web browser, it's sandboxed. That's so some sketchy website can't just peek into your online banking tab. Every single app on your phone is isolated, which is why your calculator app can't, read your text messages. It's security that's just built right in.
But look, a simple sandbox isn't always going to cut it. What if you need a really, really high security enclosure? Well, that brings us to the next level, the heavy-duty solution of basically running computers inside of other computers.
And this is what we call a virtual machine, or a VM for short. Now, this isn't just a walled-off area. Oh no, this is an entire simulated computer. It's got its own virtual hardware, a full operating system, and it's all just running like a regular old app on your main machine. It's how you can run Windows on a Mac, or a version of Linux on your Windows PC.
So how is this even possible? Well, it's all thanks to this brilliant piece of software called a hypervisor. Just think of it as the master zookeeper. Its whole job is to take your real computer's resources, the brain power, the memory, and carefully slice it up, giving each virtual machine its own little piece, and making absolutely sure they don't mess with each other. And this right here is exactly why VMs are the absolute foundation of the cloud. I mean, think about it. Cloud companies like Amazon or Google, they use hypervisors to rent out virtual servers to thousands of different people, all on the same physical machines. Your little startup server could be running right next to a giant bank's. But because of that VM isolation, you'll never even know they're there.
Now, virtual machines are incredibly powerful for sure, but they're also kind of heavy. They're big, they're slow to start up. So the tech world, being the tech world, came up with a sleeker, more modern, lightweight alternative. You can think of them as digital tiny homes.
So, meet the container. Instead of faking an entire computer, a container just packages up the application and only what it absolutely needs to run. And here's the key part. All the containers on a machine share the same host operating system. This makes them ridiculously efficient. It's like a whole neighborhood of tiny homes that all share the same foundation and utilities.
And I mean, the difference here is just dramatic. A VM is a full-on skyscraper apartment. We're talking gigabytes in size, and it takes minutes to get going. A container? That's your tiny home. It's maybe a few megabytes, and it starts up in seconds. This incredible difference in speed and size is exactly why containers have totally changed the game for modern software.
And the result of all this? Every single time you stream a movie, or order a car, or get food delivered to your door, you are almost certainly using services that are running inside containers. They are the invisible engine that powers a massive part of the internet we use every day.
Okay, so far, these invisible walls and boxes, they sound pretty solid, right? But what happens when someone tries to break out? Let's flip the script for a second and look at this whole thing from a hacker's point of view.
This right here is the absolute nightmare scenario for anyone running apps in containers. It's called a container escape. It's basically a bug or a flaw that lets an attacker punch through those thin container walls and get access to the main computer underneath. And from there, well, they could potentially attack all the other containers on that same machine. It's bad. So how do we stop this from happening? Well, we use a really fundamental security idea called the principle of least privilege. And honestly, it's just common sense. You give an app a job to do, and you give it only the tools and permissions it absolutely needs to do that one job. And then you lock up the rest of the toolshed. That's it.
And you know what? This actually brings us back to something we all deal with, those endless software updates. When you get that little notification to update your browser or your phone, it's not just about getting cool new features. A lot of the time, it's because someone found a new hole in the sandbox wall, a potential escape route. Those updates are basically essential armor maintenance.
So, as we wrap this up, it's pretty clear, isn't it? Isolation really is the unsung hero of all of modern computing. It doesn't get the glory, but without it, the digital world as we know it would be an absolute mess. It just couldn't exist. The whole philosophy here is pretty simple. We build all these sandboxes and virtual machines and containers not because we expect danger around every corner, but because we just know that chaos is going to happen. Software has bugs, people make mistakes, and bad actors are always looking for a way in. Isolation just contains that chaos, stopping one tiny problem from becoming a total catastrophe. Which leaves us with one last thought to chew on. This whole thing is a constant cat and mouse game. For every brilliant engineer building stronger, taller walls, there's a security researcher or a hacker who's just looking for a tiny crack. This battle, this endless dance between isolation and escape, it's what drives so much of what happens in cybersecurity. And the big question is always, who's winning right now?